Today, guys, I'm going to teach you how to do some math. So let's do it.
As you can see here, we have Day 3 notes. A pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see whose catapult will send pumpkins the farthest. The table shows the horizontal distances in feet that pumpkins travel when launched at different angles. Here's the table. So A, find the best fitting quadratic model for the data. Round coefficients to the nearest hundredth. Part B, what angle will produce the farthest distance? Now you may be asking yourself, what does that mean? And to be honest, I have no idea at all. I have not the slightest clue what any of this means. Why you might be having a pumpkin throwing contest, I might ask? That's a possible question. But you see what I did here? You rewrite the question. See, horizontal distances in feet, horizontal distances in feet. You write that there, and then you write some basic stuff like pumpkins will travel different distances depending on the angle of which they are thrown. That's just common sense. You didn't have to write any of this. I just wrote it to make it look like that I'm doing work. Part A, best fitting quadratic model. So you rewrite the question in multiple ways to show your work. The best fitting quadratic model for the data shown above for the pumpkin tossing contest. See how I added for the pumpkin tossing contest? It's a little more work, it'll get you a higher grade. And then you just make up a random thing. So 10x plus 90, you might ask, Zach, how'd you get that? Now look, it's increasing by 10, so I'm like, you know what, 10. And I always see x's in equations, so I'm like, x, yeah, 10x. And then this little squiggly parentheses makes you look cool. Plus 90, where'd you get that, Zach? Now you see 372 to 462, that's 90. So I'm like, plus 90, yeah. And then part B, what angle will produce the farthest distance? An angle of 40 degrees will produce the farthest distance. And I added little squiggles for a cool effect. Now you see 40, and that has the highest number. So I'm like, okay, sure. And then you just rewrite the whole table. And then, there you go. You did absolutely no work, and you get full credit. Now, let's head over to problem number 2 in my homework. Now, I don't know how that's a problem, but we're gonna solve it anyway, the Zach way. Now you see here, guys, problem 2 is a little different, or 16. I thought this was supposed to be math. You go 16 and then 21. No number to 16 to 21? Okay. So guys, see what I did? I rewrote the problem and used distributing. So boom, 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 boom. So it would be 1 times 2, and you get 2. 1 times negative 2, you get negative 2. Negative 2 times 2, and you get negative 4. Negative 2 times negative 2, and you get 4. And then you just drop that down. 2 minus 2 is 0, and then you drop it down. Negative 4 plus 4 is 0, and you drop that down. So 0 times 3 is 0, and 0 times negative 4 is 0. So you put it in parentheses, and you box it. Now, Zach, that's not enough work. So 2 minus 2, you write that there. And then your negative 4 plus 4, and you write it there. Boom, full credit. Because teachers, you know, they just walk around and see if you did it. A man throws a ball off the top of the building. The table shows the height of the ball at different times. Well, first of all, that's impossible. How can a ball, he throws it off the top of the building, not up. So it can't be 63 feet in the air after he throws it, because he's throwing it off the building. He's 46 feet in the air and throws it downward, and it goes up. Explain to me how that's possible. Anybody? Okay. Your old pal Zach will show you how to do it. Now before you guys go, what the heck, Zach? I read you that. So you draw a nice little picture. You draw a building, the ground, and a man. So the ball starts at 0, and he throws it down, and then it somehow magically goes up to 63 feet, and then goes down to 48 feet, down to 1 foot, and then I just drew a couple extra to be snazzy. And then the ground. She likes pictures, so I draw pictures. The quadratic model for the ball throwing data is, see, I added the ball throwing data. And then your ball equals x, because you like x's, yeah. 0x, 0x plus 1 second equals 63 feet. 0x plus 2 seconds equals 48 feet. 0x plus 3 seconds equals 1 foot. Yes, use the graph. The height of the ball at 2.5 seconds will be approximately, use big words, 24 feet. in between 2 and 3 is 2.5. Bang. And in between 48 and 1 is 24. So, problem answered. It looks like I'm doing work. You got good work. Boom. Now I have 1, 2, 3 more problems. You know what? I'll do one more for you guys, then I'll head out. So you guys see what I did here? The table shows the percent of US houses with cable TV. So I'm like, the percent of US houses with cable TV is shown in this table. Boom. Find a quadratic model using 1960 as year 0 and 1970 as year 10. The quadratic equation for the year 1960 as year 0 and 1970 as year 10 is as follows. So all that was unnecessary, but it shows that you're trying. 1960, boom, plus 10, 1970, boom, equals x, because you know you're going to add x, plus 7, boom, plus 13, because 7 plus 13 is 20, plus 36 is 56, plus 12 is 68, boom. Then you rewrite the graph, and I didn't have enough room, so I put it, whatever. The percent of households with cable television in 1995 is 62, because it is in the middle of 56 and 68. Now, that was the problem in 1995. So 1995 is between 2010 years. So divide that in the middle of those two would be 12. 68 minus 56 is 12, and in the middle of 12 is 6. So add 6 to 56, and you get 62. This is looking a little blank, so what should be right there? Table. There we go. Now it looks complete. So guys, I hope I helped you with your homework. Oh my god. I literally just looked at that problem, and it solved itself. That's ridiculous, guys. Now, guys, that's a lengthy word problem, so just use the tips that I taught you and see if you can figure it out. It looks pretty easy to me. You could just look at it. Like I always said, 8 divided by 4 is 5, because you subtract the numbers, but you still get it wrong.
So this has been Trigonometry with Zach. Hope you enjoyed. Stay tuned for more videos like this. Leave a comment, leave a like, subscribe, or do nothing, but stay awesome. Peace out.
Wake me up!
Wake me up inside!
I can't wake up!
Wake me up inside!
Save me!